Welcome to This Explainer. We're jumping straight into the massive, unseen engine that's literally driving the modern world right now. Look, if building an artificial intelligence is like launching a rocket, well, evaluating that AI, that's the navigation system we desperately need so we don't fly completely blind. I mean, we constantly hear about how incredibly powerful these models are, right? But how do we actually know they're smart, safe, or even accurate? To figure that out, here's our roadmap for today. First, why we grade AI. Then, the accuracy paradox, humans versus machines, judging AI creativity, and finally, moving beyond right and wrong. Section 1. Why we grade AI. It is the absolute engine of progress. There's this golden rule in AI. Developers optimize for what they measure. So, evaluation isn't just some final stamp of approval at the end of the day. It's literally the engine of progress. But how do we actually measure this stuff? Well, think of end-to-end evaluation like taking a big bite out of a fully baked cake just to see if it's any good. You're testing the entire unified pipeline exactly how a user would experience it. But hey, if the cake tastes terrible, you have absolutely no idea why. That is exactly where component-wise evaluation comes in. It's like tasting the raw ingredients, the flour, the sugar, the butter, all in isolation, just so you can pinpoint exactly which module went wrong. Section 2. The accuracy paradox, a mathematical illusion. Now, as we start scoring these digital exams, I've got to warn you about something. What seems like a super obvious grading metric can actually be a massive illusion. Think about this. Can an AI be almost 100% accurate and still completely fail its test? I mean, it sounds totally impossible, right?
Well, what if I told you an AI could score 99.998% on a test and be absolutely, completely useless?
Seriously, imagine we've got a massive data set, like 1,000,000 documents, and we need our AI to find exactly 10 rare, highly specific files. A totally lazy, naive AI could just guess, no, it's not the target, for every single document it looks at. And you know what? It would be correct 999,990 times. Mathematically speaking, that gives it a staggering accuracy of 99.998%. But it failed to find even a single correct target. It completely missed the entire point of the test.
So how do we catch a lazy AI like that? We use what's called a confusion matrix. Basically, there are 2 ways to be right and 2 ways to be wrong. A false positive is essentially a false alarm. The AI selected something it really shouldn't have. But that lazy AI we just talked about, it committed false negatives, which are missed targets. By meticulously tracking these specific errors using metrics like precision and recall, we completely shatter that illusion of raw accuracy.
Section 3. Humans versus machines. Who exactly holds the red pen? So on one hand, we have human evaluation. This is the absolute gold standard for sure, because we humans intuitively just get context and nuance. But let's be real. Human evaluators are expensive, they're slow, and they can be highly subjective. Now, on the other hand, we have automatic evaluation by an algorithm. This is cheap, and it's near instantaneous. The catch? It struggles massively with the ambiguity of human language. For example, if an AI gives a perfectly correct answer, but just happens to use a synonym that the automated system wasn't explicitly programmed to recognize, boom, the AI gets marked wrong.
To bridge that frustrating gap, researchers came up with a pretty clever post-editing method called translation edit rate. Here's how it goes. We let the AI generate some text, and then a human editor jumps in to fix it up. But instead of just asking the human for some subjective score out of 10, we grade the AI strictly by the physical labor involved. We're talking the literal time and keystrokes it takes a human to clean up the AI's mess. It makes perfect sense. A model that only requires 5 keystrokes to fix is obviously way better than one that takes 40.
Section 4. Judging AI creativity. This is where grading gets incredibly subjective. See, when we start grading highly ambiguous tasks like generating essays or doing translations, we leave simple math behind and enter a bit of a subjective nightmare. For years and years, the absolute industry standard for this was the BLUE score, which stands for Bilingual Evaluation Understudy. Because language has so many valid variations, BLUE relies on a core heuristic. It checks for structural similarity. It basically assumes that the more an AI's generated test looks exactly like a trusted human-written reference, the higher quality it must be. Algorithmic-wise, here's how it actually pulls that off. It chops sentences up into tokens and matches those word sequences directly against the human reference. But here is the thing. AI will absolutely try to cheat.
If the model just repeats the word "the" 100 times just to rack up easy matches, Blue catches on and mathematically clips those inflated repetitions. And what if the AI just outputs a single correct word and completely stops? Nope, it gets hit with a strict brevity penalty.
Fast forward to today, though, and we've got this fascinating modern twist, using LLMs as judges. Instead of relying purely on rigid, hard-coded math formulas like Blue, researchers are now deploying highly capable large language models to evaluate other models. This is a total game changer because it allows us to judge incredibly abstract semantic dimensions. Think about it. A judge LLM can read an output and actually score it on whether it was genuinely helpful, harmless, or relevant. Those are concepts a simple word matching script could literally never comprehend.
Section 5. Beyond right and wrong. Time for the behavioral exams. Okay, now we really need to elevate the stakes here, moving from basic mathematical correctness to actual real-world impact. Take adversarial robustness, for example. Imagine we start with a perfectly clean image of a panda, and the AI correctly identifies it. Great. But then attackers sneak in this tiny mathematical noise tweak to the pixels, just a 0.007 adjustment. To you and me, the image looks exactly the same, totally unchanged. But that practically invisible tweak completely tricks the AI into hallucinating. Suddenly, it is 99.3% confident that this panda is actually a gibbon. It's wild, and it's exactly why we have to rigorously test for these hidden vulnerabilities. But, it's not just hackers we need to worry about. It's our own history. AI systems can completely fail their fairness exams just by absorbing historical human prejudices right out of their training data. Decades of human stereotypes about different occupations literally get locked directly into the AI's mathematical word embeddings. So the model's internal logic starts strongly associating words like nurse, housekeeper, and librarian with females, while aggressively skewing terms like carpenter, engineer, and mechanic to be heavily male. And these biases, they have severe, real-world consequences. Just look at this incredibly stark metric from a landmark audit on facial analysis. When researchers tested a major commercial classification system, they discovered that gender was misidentified in 35% of darker-skinned females in the test set. 35%! That exposes a massive, fundamental failure in the model's ability to generalize. And it proves exactly why deploying unevaluated, biased systems is just incredibly dangerous for all of us in society. So, with all that on the line, how do we actually make sure our tests are working? We use meta-evaluation. Because, at the end of the day, all of these metrics, from the Blue scores to those fancy LLM judges, they're all just proxies. So we literally have to continuously evaluate our evaluation methods. We rely on rigorous statistical tools like Cohen's kappa just to measure whether different human graders even agree with each other. It's all about ensuring that our grading rubrics are scientifically sound and that they actually map to real human preferences. Which brings us to a final, slightly provocative thought to wrap up our journey today. If the ultimate goal of all this AI is genuine human utility, but we fully know our human evaluators carry their own personal biases, and our AI judges just inherit those broader societal biases, who ultimately judges the judges? Evaluation isn't just some cold math problem, it's actually a philosophical mirror reflecting our own human values. Keep that in the back of your mind the very next time you see some flashy headline bragging about a perfect AI score. Thank you so much for joining me for this explainer, and I really hope this leaves you absolutely eager to dig even deeper into the wild world of AI alignment.